Hi, let's take a look at how we can use the law of sines to solve real-life problems. And I've selected two problems to work from your textbook on page 414, problem 26, and then number 31 we'll look at. Problem 26 says you're standing 40 meters from the base of a tree that is leaning 8 degrees from the vertical from you. The angle of elevation from your feet to the top of the tree is 20 degrees 50 minutes. We need to draw a triangle that represents the problem, write an equation involving the unknown height of the tree, and find the height of the tree. So let's look at the way we can draw this triangle. It says that the angle of elevation to the top of the tree, so think about here's a tree here that's leaning, okay, my pretty tree here, whatever, but it should be leaning, okay, away from you. And the angle of elevation from where you're standing 40 meters away to the top of the tree is 20 degrees 50 minutes. And then it says the angle is leaning 8 degrees from the vertical away from you. So if you think about the vertical makes a 90-degree angle, and 8 degrees is this angle here, and the right angle is 90 degrees, so the two together are going to be 98 degrees. Okay? So it might even be better if you can draw that triangle without everything. Oops. Let me make that more of a obtuse angle right there. Okay, so we have a 98-degree angle here, then we have a 20 degrees 50-minute angle there, and then we have this side is 40. And what do we need to find? The height of the tree. So if this is angle A, B, and C, we need to find the value of A. So to do that, we first need to figure out what angle C is, because that's the other side we know. So in our law of sines, we need to set up sine C over C. So to find angle C, we will subtract the two given angles from 180. So we do 180 minus 98 minus 20 degrees 50 minutes. So that's 180 minus 98 minus 20.83. Recall that 50 minutes you divide by 60 to get the decimal equivalent of that. So we have C is 61.17 degrees. So now we set up our ratio of A over sine of 20 degrees 50 minutes, or 20.83, is equal to C, which is 40, over sine of 61.17. And we multiply by the sine of 20.83 degrees. Use our calculator. We come up with the height of the tree is 16.24 meters. Now let's look at the next problem, which is problem 31. It's a little bit more involved. We have the bearing from Pine Knob Fire Tower to the Colt Station Fire Tower is 65 degrees east of north, and the two towers are 30 kilometers apart. A fire spotted by rangers in each tower has a bearing of 80 degrees east of north from Pine Knob and 70 degrees east of south from Colt Station. Find the distance of the fire from each tower. Okay, so let's think about everything that we know here. If we have a 65-degree angle and an 80-degree angle that we're told about, then the angle inside the triangle is 15 degrees, right? Just the difference between those two. So that is the first angle that I found there, is at 15 degrees. Now, the other thing that we know is that we're looking at a set of parallel lines, right? Our north degrees. Or if you think about a vertical line going from north to south, those are parallel. And do you remember a big fact in math and geometry basically is if you have two parallel lines cut by a transversal, which basically means another line, then you get alternate interior angles are equal. So if you can kind of visualize this, we have two parallel lines cut by another line. We know that this angle is 65 degrees from our diagram. Then that means that this angle also has to be 65 degrees. So that's how we obtained the measure of that angle of 65. Well then, because of that vertical line going from north to south there through that picture, we have really two triangles, one contained adjacent to the other. So we can figure out what the other measure has to be. If we know 15 and 65, their sum is 80, so subtract from 180 to find out that this has to be 100 degrees. And then when you have two angles that are adjacent to each other that form a straight line, they have to add up to be 180, right? So if this one is 100, the one adjacent to it has to be 80 degrees. We knew the 70, so we can add the 70 and 80 to get 150, which remains 30 degrees for this other angle. Okay, so we had to go through a lot to figure out what the three basic angle measures were in that triangle. But through that, we have found that we really have a triangle that we're talking about that has 15 degrees, 135 degrees, because we add up the 65 and 70 to get 135, and then the 30. And then we know a value of the side, which is 30 kilometers. So now it's just a matter of setting up our law of sines to figure out what the value of A and C has to be in this problem. So really the kicker to this was understanding that I had to figure out what those interior angles were to figure out then how to use the law of sines. So to use the law of sines, we just set up A over A, which we don't know, over sine of 15 is equal to B, which we know, which is 30, over the sine of 30. And we can multiply by sine of 15. So we get A is 30 sine 15 degrees over sine of 30 degrees. Use your calculator and you'll find that A is 15.53 kilometers. And then we do the same thing to figure out the value of C. C over sine of 135 degrees is 30 over sine of 30 degrees. Multiplying by sine of 135, we get the C is 42.43 kilometers. So that's how you're going to have to apply the law of sines to some of these application problems. If you have any questions, please contact me. Thanks.